Pick Computing, A-Level Computing video number 58, looking at algorithms and flowcharts. So what's the rationale behind algorithms and flowcharts? Well, we've looked at top-down and modular design, and in particular structure diagrams, and you will have looked previously at data flow diagrams too. Now these different methods only portray data that is needed in a program and where that data is going to be transferred from and to. So although that is some detail, we might want more detail when designing a computer program. Algorithms go into more detail by portraying what a program will do with the data that has been input in order to create output. I like to know an algorithm as the step-by-step procedures needed in order to solve a problem. Accurate design of algorithms is essential for a program to work properly. They should show the order in which instructions should be executed. Algorithms are essentially the logic within the program. They're the brains of the program. They're the intellectual property of the program. They're typically portrayed in two different ways: flowcharts and pseudocode. In our next video we'll look at pseudocode, but this video we're going to concentrate on flowcharts. So, flowcharts then. These use a diagram to show the different steps in an algorithm. We have symbols that follow standard conventions, and if you want a bit more of an introduction to flowcharts, I suggest you check out video number 5 of A-Level Computing on the PIC ICT YouTube channel. Here's an example of a simple flowchart that represents a very basic login system. So if we look at the top, the flowchart starts off and first of all asks what we call for an input, where the user inputs password and clicks on log on, and then we come down to what's called a decision. Does the password equal Apple? If not, output an error message and the user has to start again. If the user's got the password correct, they have put in Apple, then we output a success message, and then maybe the home page or the desktop or whatever should load up for the user does load up next, and then the flowchart ends, the algorithm ends. So let's look at those different symbols in a little bit more detail. There's something called flow lines, and those are the lines that you always see, the arrows between different symbols on the flowchart, and sometimes they'll have things written next to them, sometimes they won't, but those arrows are what you need to follow in order to follow the flow of the algorithm, the flow of the program. All flowcharts should have start and stop symbols. They might also be known as terminators. They look a bit like this. The beginning ones will say something like start within them and then have an arrow coming out of the bottom of them. The stop ones should have an arrow going into the top of them because they happen at the end. And you might see different words in there, like I just mentioned, such as begin, end, finish, etc. A process is denoted with a rectangle, and we'll have an arrow coming into the top of it and coming out of the bottom of it, and we'll have a piece of text inside the rectangle saying what happens in that process. So there's an example, and there's another example where something's happening to a variable within a program. So 1 is being added to X within this process. Input or output symbols are denoted using parallelograms or drunken rectangles. They look a bit like, don't they? Again, arrows in and arrows out. An example of an input might be something like user inputs a price. An example of an output might be for a message box to say something like too much. A decision is shown with a diamond shape. Now decisions are a little bit more complicated than some of the other symbols. A decision is where the algorithm needs to make a choice. The computer program needs to make a choice, and there will be a question within the diamond shape. So we should always be looking to put a question mark into any of the diamonds that we have on a flowchart. There will be an arrow coming into a decision, but there'll be more than one arrow coming out of it. And next to those arrows we'll be putting some answers. So does x equal 10? If the answer is no, then the flow of the flowchart will go off to the right hand side and something will happen over here. If the answer is yes, x does equal 10, then the flow of the flowchart will go down and something will happen further down below. Other things that might get written on the two arrows are true and false, possibly. When there are only two options coming out of a decision, it might be known as a Boolean decision, but decisions sometimes have more than two options. If we think about something like a combo box where there are choices in a drop-down list, if we were to show that in a flowchart, it might look a bit something like this. But instead of two arrows coming out, we might see one arrow branching off into four different arrows to show the four possible outcomes from that decision. There are two types of symbol that help make flowcharts more efficient, easier to read, more maintainable, etc. And the first one is a subroutine, and that uses a rectangle with two dividing lines within there. And a subroutine in a program is a piece of reusable code, basically. So an arrow going in, an arrow going out, and then something like convert into euros. So if we've already written a flowchart that does the conversion into euros, and that conversion is going to be used by another algorithm, then we could denote that when the flow of this program comes down to this shape here, then we'd need to reference another flowchart. We'd need to go and look at another flowchart to see how the conversion in euros is done, and then we can continue with this main flowchart. So look out for an example somewhere that uses a subroutine. The other type of symbol that helps the ease of flow within a flowchart are connectors. And connectors are where we might have really big flowcharts that are just too big for one page. So a flowchart might stop at connector B and continue at connector B on the next page. So an example here is not where one goes off onto two pages, but is where the flow of the flowchart here stops at part A and then could resume at part A over here. So how will you be examined on flowcharts in your F452 exam? Well, typically you'll have to use or create a flowchart within a question. You may be given a flowchart and then some data. You'd use the data to feed into the flowchart to get some answers. So you'd have to follow the flow of a flowchart with a given bit of data to see what a result comes out at the end of it and record the result. Other things you might have to do are to complete a flowchart that has been started. You'd get given the rules of the algorithm in English in some narrative, and then have to complete the flowchart based on that, or even just draw one from scratch given some narrative. Ask your teacher for some examples and get practicing, because you will get asked about flowcharts on this exam. Good luck with that.